The question says which electronic configuration for oxygen is correct according to Hund's rule of multiplicity. According to Hund's rule, orbitals are filled with single spin first followed by double spin. Okay, this is the condition we need to follow for the electronic configuration of oxygen. Okay, first of all we write down the electronic configuration. Oxygen atomic number is 8. We have electronic configuration 1s2, 2s2, and then we have 2p4 is there, 2p4. Okay, now we write orbital notation. Okay, so in this case only one box is there, will fill these 2 electrons. 2s2 is there, in this case also 2 electrons are there, but in p case this is a p subcell, and in p subcell how many orbitals are there? 3 orbitals are there. How many orbitals? 3 orbitals. We have px orbital, py orbital, and in the last we have pz orbital are there. Okay, in these orbitals we have to fill how many electrons? 4 electrons we have to fill, and when we fill these electrons in these orbitals we must follow Hund's rule. Okay, so according to Hund's rule, these orbitals are filled with single spin first followed by double spin. Okay, so let's start filling. First electron single spin, second electron, and this is the third electron. Now we can double. Okay, then 3 electrons fill, total 4 electrons. I fill the last one also. So this is the arrangement of electrons in orbitals according to Hund's rule. Okay, so the electronic configuration we get for oxygen, that is 1s2, 2s2, then we have, you can see it is the second cell, so we can write 2px, 2py, 2pz. So we have 2px. In 2px how many electrons are there? 2 electrons. Then 2py. In 2py how many spin are there? Only 1. And then we have 2pz is there. In pz how many spin are there? Only 1. Okay, so this is the electronic configuration we get according to Hund's rule. Any such option given here? Okay, we have first option. You can see first option is correct. First option is correct. If you like this video, please share and subscribe to the channel.